Hello everyone. In this lecture, you will understand the timing diagram of skew concepts. So in today's lecture, I am going to cover timing diagram for two concepts, namely positive skew and negative skew. Okay. So as we discussed in the previous lectures, a positive skew is obtained in the circuit when both input flow and the clock flow are in same direction, whereas we will get negative skew in the circuit when both input flow and the clock flow are in opposite direction, right? So now we'll have a look at how to draw the timing diagram for positive skew. Let's start with the positive skew concepts. Okay, so you look at here, this positive skew circuits. It consists of resistors and combinational logic circuits. Okay, you look at the clock signal, the main clock signal or global clock signal in positive skew, which is located at left extreme, whereas in the case of negative skew it is located at the right extreme, right? This positive skew, in positive skew, the lower order register, the register R1, which is located immediate to the clock signal, whereas the higher order register like R2, R3 and R4 so on is located somewhat distance from some distance from a clock signal. You look at the timing diagram for positive skew, the first diagram. This diagram corresponds to positive skew. This clock signal, this is the main clock signal that is supplied to all the registers inside the sequential circuit. You look from, we can observe from this diagram, register R1 will receive clock signal without any delay. So therefore this dotted line, right, this dotted line represents the reference signal of a main clock signal of main clock. So therefore you look at the clock 1 signal. The clock 1 corresponds to register R1, whereas clock 2 corresponds to register R2, okay, and clock 3 corresponds to register R3. You will take like this, okay, whereas the clock 1 signal corresponds to register R1. So R1 receives main clock signal without any delay. So therefore the reference line is aligned with the main clock signal. The clock 1 signal is aligned with our main clock signal. Okay, if you look at the case of R2, so R2 will receive the clock signal after this delay. Because of this delay present in the path, R2 will receive clock signal after a delay of delta. Okay, so this one. So therefore you look at here this one. So this is the clock transition, or the first time the register R2 will receive the clock signal. So therefore there is a phase shift between the main reference signal with the clock signal of register R2. Okay, so therefore the register R2 will have a single delay or delay of uh, a single delay. Okay, whereas in the case of register R3, we will find that there are two delays present in the path. So therefore register R3 will receive the clock signal after twice the delay. So this twice the delay we will receive the clock signal. This is quite clear. It is very easy to understand the timing diagram. So this is the main clock signal that is distributed to all the registers, whereas different registers will receive the clock signal after depending upon the delay present in the path. Clock 1 is corresponds to register R1. R1 will receive the clock signal without any delay, whereas R2 will receive and after a single delay. We will consider like this. Okay, in the case of the register R3, it will receive after the twice the time of delay, right? So now we will have a look at the negative skew. You see, in the case of negative skew, the clock is located at the right extreme. So therefore the higher order register will receive the clock signal first, and the lower order register will receive the clock at last. Here let's consider, let me put the clock 3 corresponds to register R3, and then clock 2 corresponds to register R2, then clock 1 corresponds to register R1, and this is the main clock signal. Okay, this is the main clock signal that is supplied to synchronous circuits. Okay, this is the main clock signal. So since register R3 will receive the clock signal without any delay, this red dotted line is the reference line, as I said, as I mentioned in the positive skew. So register R3 will receive clock signal without any delay, therefore this signal, so therefore there is no phase shift between main clock and clock 3. If you look at the register R2 will receive the clock signal after a delay, so the delay is this delay. Okay, so you see the difference between the phase shift between the main clock and clock 2, so there is a phase shift of delta. Okay, so that delta is represented by this area. Okay, whereas in the case of register R1 receive the clock signal after a delay of twice, so this delay is this one. Okay, these two delay. Okay, the clock 1 and then clock 2. So I hope the concept is quite clear. Okay, so I will back with the new lesson in the upcoming lectures.